Hello friends, today now we are going to discuss the point that is known as reversible and irreversible processes. So both the reversible and irreversible processes are the thermodynamic processes. Okay, what do you mean by thermodynamic process? Yes, anyone? What do you mean by thermodynamic processes? All of you know that if we consider any system, and system has different states at different time. Suppose the thermodynamic system has one certain state that is called as state A. When this state is considered, then you have to consider the state variables. So what are these state variables? If we consider a gas cylinder, then the state variables are different. If we consider any one bottle, water bottle, then state variables are different. So already we have discussed all about this. Now the thermodynamic process is that process in which the one state of the system changes to another state. So state A changes to state B. When the system changes from one state to another state, then their state variables get changed. Suppose we consider this state is a one cylinder. Whatever the state you may consider, then you have to consider one, that is the cylinder. This cylinder is having pressure, piston on the pressure is P, volume of the gas is filled inside is V, and T is the temperature. Or you may call it that P1 is the pressure, V1 is the volume, T1 is the temperature. Now this state changes to another state. Let's say this state is changed and the state becomes now pressure P2, volume V2 and temperature T2. When you draw the indicator diagram, then you know that the indicator diagram is the graph between any two variables of the state, two states. Suppose we have to draw the state variables P and V. Then this, that is the state representing P1, V1, T1, and this state changes to, that is the B, P2, V2, T2. So P1, V1 and P2, V2 will get changed. So that the state A changes to state B. Now consider, the state changes from A to B is in one direction, like this direction. If the state is slowly changes, that means it is called as a quasi-static change. Quasi-static means very infinitesimally slow. If the state changes to very slowly, then that trace, that means the graph between P and V are anyone, that can be retraced back at any point. At any point. That means when you consider this state A, it is going to change in this direction. If direction of this state reversed at any position from either B or any point in between A and B, with the condition that there is no loss of energy, then this, that is the change in state from A to B and again retraced back to A, this is called the reversible process. So reversible process is the thermodynamic process in which each and every step is very slowly changes. If suppose some energy is lost during the direct changes, then in reverse changes the same amount of energy is gained by the system. Same amount of energy is gained by the system. Suppose this pressure is now changing. If pressure changes, volume changes, temperature also changes. When temperature changes, the same amount of energy changed with temperature is given out to the surrounding, and now this state becomes B. This state becomes. If again pressure is decreases, then the amount of energy given to the surrounding is again absorbed, and again this state becomes as it is. That means at pressure P1, volume V1 and temperature T1 without loss of energy. That process is called as a reversible process. So you may take one example. Suppose 1 gram of ice. You should consider 1 gram of ice. If you provide some amount of energy, that means 86 calorie energy, this ice is at 0 degree centigrade. Isn't it? It is at 0 degree centigrade. When ice absorbs some amount of energy, then this ice is converted into water. Ice is converted into water. What? Liquid. But its temperature again remains same. That means crystalline nature of the system changes to liquid state. Solid changes to liquid state by absorbing some amount of energy. But temperature also remains same. Temperature, that is, it is the fusion. This is that will get fused to water, or it is called also liquefaction. Now, when this water releases, this water gives 86 calorie to the once again surrounding, then again it becomes ice at the same temperature. So that means when you absorb some amount of energy, ice converts into water, and again releasing some amount of energy, same amount of energy, water again converts into ice. This is the reversible reaction, or this is also called as reversible process. Similarly, one more example you may take. That means another example. 1 gram of water, 1 gram of water at 100 degrees centigrade. At 100 degrees centigrade. If we provide to this water 536 calorie energy from outside, then this water is going to become a vapor. So vaporization takes place. This vapor is also at 100 degrees centigrade. There is no change in the water to vapor when there is no change in its temperature. It is isothermal process. This is also isothermal process. So when this vapor will use 536 calorie energy to back to the surrounding, then again this vapor converts into water at the same temperature. So temperature of this state or system doesn't change. This is also called as the reversible process. So the reversible process is the isothermal process. This is also isothermal process. Reversible process is also the adiabatic process. That means adiabatic and the isothermal process are when you taken as very slowly, infinitesimally, or it is called as quasi-static. That means very slowly. Then all the processes are retraced back. There is no loss of energy. Then those processes are called as reversible process. There are very few examples in the nature where the reversible processes are possible. So what are the conditions of the reversibility? Reversibility or reversible process must have the conditions for the reversibility. Must have very slow. The reversible process must be in direct and reverse, must be very slow. Then second condition is whatever the amount of energy given or absorbed by the system or to the surrounding must be again gained or evolved to the surrounding. So energy exchange must be total energy exchange or total energy difference must be zero. That means if we provide some amount of energy from going from A to B, the same amount of energy you have to extract from B to A. So total change in energy is zero. Isn't it? So this is the possibility of reversible processes. So this is the all over about the reversible process. So reversible process must be very slow. Energy loss must be zero. Energy loss may be friction, due to friction or anything, that must be zero. Then this process must be at constant temperature, that means isothermal, or it may be adiabatic. So this process is called as a reversible process. Now, if the process changes from A to B, but do not reverse back. Do not reverse back means what? It reverse backs, but in another different path. That means if the direct process is like this, that A changes to B by some absorbing energy or losing the energy, and again it retraces back in this direction. Then during this direction there is some loss of energy or gain of energy. That means the absolute change in energy is not equal to zero. This process is called as irreversible process. Although the process changes from state A to state B, again it becomes state A, but student, you must clear that. That means although this statement state B changes to again state A, it is not reversible process when there is loss of energy or gain of energy. Means what? If I rub this two hands in this direction, then due to friction there is the energy emitted, energy produces. That amount of energy must be, when you rub in the reverse direction, that amount of energy must be regained back. But it is not possible. When I rub direct in reverse, direct reverse, but ultimately the energy go on increasing. This process is irreversible process because there is loss of energy. So when the process changes from one state to another state and return back also, or do not return back, then that process is called as irreversible process. When I am speaking here, then the food energy is converted into sound energy. This is irreversible process. When you are sitting at one place, going to other place and come back to the one same place, but this is also irreversible process because when you go and come, the energy will not be regained. Some amount of energy is lost. So almost all processes in the universe are irreversible processes. Almost all irreversible processes in the universe. That means the entropy of the universe tends to maximum. What is the entropy? We can discuss in the next video. But you must understand that the disorder of the system, disorder of the universe is tending to the maximum. That means entropy of the universe is maximum, always tending to maximum. That means there is always loss of energy. That energy cannot be gained. So when we burn petrol, diesel, then the same amount of energy cannot be retraced back in the form of petrol. If I light a bulb here, then the glow of bulb is due to electricity. When I off the bulb, then the same amount of light energy do not convert into electric energy. So that means the almost all processes in the universe, instead of few, they are all known as irreversible process. So reversible process and irreversible process are the thermodynamic processes, where in irreversible process there is no loss of energy, whereas in irreversible process there is always loss of energy. Is it? Always loss of energy means energy is converted into another form. So almost all processes in the universe are irreversible processes. Do you understand? Thank you.